In this lesson, we're going to talk about solving 3x3 systems of equations. We're going to do so using matrices. So we've already talked about two equations and two variables. Now we're going to add a variable and an equation. So some vocabulary. First, a term that we should know, coefficient, is the number that's in front of a variable. Okay? Coefficient is just the number in front of the variable. And like I said, we're going to use these things called matrices. Yeah, that's plural for matrix. A matrix is a rectangular array of coefficients in rows and columns. So for a matrix, we're going to draw these like squared brackets here, like we did for a domain and range. And they're going to be in rows and columns. So columns will go up and down like this. This is a column. And we have rows go like this. And when we write how many, what kind of matrix we have, we're going to say it's the number of rows by the number of columns. And that's how we're going to define our matrices. Okay? So let's put this into action. So here I've got my first matrix with 3 equations and 3 variables. We have an x, a y, and a z. So what I'm going to do is I'm going to label and I'm going to put all of these terms or these variables into their own column here. So I've got an x column, a y column, a z column, and then an equal sign, which would be for these numbers over here. And then each row is going to be a new equation. And so what we're going to do is we're just going to take the coefficient of each of these terms, and we're going to put this into our coefficient matrix. So first I have negative 2x, so I'm just going to write negative 2. And I'm not going to put any commas or anything like that. I'm just going to leave a little bit of space and say we have then 2y's, positive 2. We have 1z, and it's equal to 14. So just the numbers straight across. Then we've got 3x minus 2y's, 1z, and negative 5. Then we have negative 1x, 1y, negative 2z is equal to negative 8. And so now I've got my coefficient matrix. And what we want to do is we want to find the reduced row echelon matrix, or RREF. And we're going to do this in Desmos, so I'm going to hop over there now and we're going to take a look at it. So I've got my Desmos Matrix Calculator here. And so to get a matrix, we're just going to click this New Matrix button. And now I need to adjust the number of rows and columns. So I've got 3 equations, so I need 3 rows. And I need an x, a y, a z, and an equal sign. So I need 3 rows and 4 columns. And now we're just going to type in what we wrote down. So I've got negative 2, 2, 1, 14. And I'm just pressing tab to get in between all of the different spaces here. I've got 3, tab, negative 2, tab 1, and that's equal to negative 5. Then negative 1, 1, negative 2, and negative 8. And when I'm done, I can just press enter. And so now we see that matrix A is equal to this matrix here. And so all we have to do now is press our RREF button, and then we're just going to type our matrix, which it labeled this one as A. So I'm going to type RREF of A, and it gives me this matrix back. So now let's write down what we found. We know my x, y, z, and equal. And this was 1, 0, 0, negative 3. Then we have 0, 1, 0, 1, and 0, 0, 1, 6, positive 6. Okay? And now we can use this to find our solution. We want to write our solution as point x, y, z. And lining it up in these columns here makes it really easy to see what we've got. So we've got 1x is equal to negative 3. We know that 1y is equal to positive 1. And 1z is equal to 6. So I'm going to say x is equal to negative 3, y is equal to 1, and z is equal to 6. And that's how I find my solution to a 3x3 system. Let's do one more example. Here I've still got 3 equations, right? 1, 2, 3. But I also only see two terms in each of my equations. But I still have an x, I still have a y, and I still have a z. So I still have 3 variables, just not in each equation. So we're going to have to make note of that when we make our coefficient matrix. So let's still say it's x, y, z, and equals. And now let's just be super careful when we plug in our coefficients. So I've got 2 x's in this first row, but I don't have anything written for y. So I'm going to say I have 0 y's, and then I have 3 z's, and that's equal to 1. Then I have 3 x's. I have negative 5 y's, but I have 0 z's, and that's going to be equal to 10. Then I have 0 x's. I have 4 y's. I have negative 3 z's, and that's equal to 13. So now let's jump back to Desmos and find our RREF matrix. So now I'm back in Desmos now. And we can either press new matrix, you can clear this all out, but I think it's quickest to just come back up here and just edit our original matrix that we had. So I'm going to type in 2, 0, 3, 1, and again just pressing tabs will go and highlight all of these. Negative 5, 0, 10, 0, 4, negative 3, and 13. And you may see that as we're actively typing, it's updating our RREF matrix, and so I get that here. So let's jump back to the notes and write this down. So let's write this down. We've got x, y, z is equal to 1, 0, 0, 5, 0, 1, 0, 1, and 0, 0, 1, negative 3. So my solution, 1x is equal to 5, 1y is equal to 1, and 1z is equal to negative 3. So my solution is 5, 1, negative 3. And this has been how we find solutions to systems of 3 by 3 systems. Good luck in your practice, and I'll see you in the next video.